Western Canada. So really excited to kind of focus today's conversation on really what we're doing out there with all these various partners and customers of ours to really optimize IoT and kind of walk through what those considerations look like, for customers that are trying to build things that are, frankly, giving them that future-proof platform to hopefully innovate and thrive and survive in this crazy world that we're living in right now. So I just kind of introduce myself, and I'll let Kyle introduce himself as well. Chad Arnold, I'm the Director of Sales for Equinix for the broader Pacific Northwest and Western Canada. I've been working in the Western Canadian space for just over 4 years now, and look forward to chatting today. Go ahead, Kyle.
Hi, nice to meet you, everyone. Good morning. As Chad mentioned, I was very happy to be here to kind of share some of the information that we have seen so far. So I'm actually working out of the Equinix headquarters here in the Bay Area. I am a Canadian. I grew up in Vancouver, but I live here in California now. So we'll be able to give you some insights into what we see from the industry and also a solution perspective. Chad, back to you.
Thank you, Kyle. So if you want to go ahead and advance to the next slide, I'll take control here in a moment. But what I really wanted to kind of start with, just real quick to level set the agenda, we're going to talk a little bit about Equinix. I'm going to kind of just highlight what it is that we've been doing, within Western Canada, the trends that I'm starting to see, some of the use cases that we've implemented with customers, and things that are actually coming around the bend. And then Kyle's going to go into a little bit more detail about some of those specific cases and impacts that they're having both on Western Canada and the global IoT space as well. So I'll move this forward here. It should advance. There's a slight delay. 1 second. Kyle, it might be just faster if you go ahead and advance that slide. There we go. Right on. So the first key that I like to kind of focus on when it comes to IoT and our relevance within that space is the fundamental, it's latency, right? Data proximity to any device in the IoT world is critical to performance. And we talk a lot about this, but this is one of the biggest challenges that for enterprise customers that might need to be, pulling more data or doing more analytics on a device that, whether it's near cloud or very far from the cloud, that proximity has a real impact on the performance. So this is one of the first things that we really address, and we'll highlight why, but this is one of the first things that we really talk about with a lot of customers. We'll go to the next slide here. The next thing there is really, it's about security. As we start to move and think about how are we encrypting data as it flows across these multiple devices from more far-flung remote sites, moving towards devices that might now be virtualized across a broader wide area network that require more analytics. How are we securing that data? And one of the really interesting concepts there is if you think about where the majority of security breaches are occurring, it's occurring from traffic that's moving over the internet. So one of the things that we think about in our architectures is how can we actually take as much of that traffic off the internet as quickly as possible? Obviously, the internet is critical to attach and provide access to any one of these IoT devices in the field, but how are we securing that and optimizing that platform across which that data is actually being transmitted? And this completely changes, by the way, as folks move more from their legacy environments towards a more IoT-enabled platform. So the final piece of this is really about the fact that when we think about IoT, there are things being done, compute resources being provided, whether it's in Microsoft or Amazon, Google, Oracle, down the list of public clouds and other clouds you might not have even thought of or heard of. That choice is critical. And so to be able to not only solve for the physics of moving data, consuming data, analyzing data, but also then determining how and where is that data being analyzed, it's really important, because if we put all of our eggs in one basket, so to speak, what we're finding is that there's so much innovation occurring within every cloud that to give yourself the choice to be able to leverage the right cloud for that right workload at the appropriate time is critical. And that's a really big part of the relevance that Equinix has in this broader conversation. So when you think about what it is that we're really solving for, fundamentally, it comes down to really four key things. And I'm going to try and advance the slide here. It's a little slow for me. There we go. So we talked about the first three here, right? So the performance by solving for latency, the choice, because every public cloud in the world, every SaaS platform you can think of lives at Equinix. But then those security paradigms are completely unique. These are unique architectures that you haven't necessarily implemented yet. So how do I leverage these new environments without putting that data at risk? These are all the things that we're solving for. And digital transformation, it really is a buzzword. You know, when I think about what it means to each customer that we work with, it's something different for everyone. And I think that the critical piece here, especially now, is so many enterprises and public entities that we work with have been forced into transformation. In a lot of ways, COVID-19 has actually forced some things to be changed because the legacy platforms couldn't accommodate for this scale. So how do I avoid overloading my IT infrastructure, right? And I think what's interesting about this slide is that when you think about the number that it represents, 4.7 million remote workers utilizing distributed IT, that number has actually quadrupled or more since the onset of this recent pandemic. So this is becoming more and more relevant as we move forward. So why are we a part of this conversation? This is the so what slide. So 96.4% of all global internet traffic is flowing through Equinix data centers. And yes, oh, by the way, Equinix is a global data center operator. But why is that important? It's that our facilities, these global data centers that we own and operate, represent the intersections of the internet. It's where every network comes to peer their traffic. So you think about Shaw and Rogers and Telus and Bell and Zayo, Legacy, Allstream, all of these routes, you know, for Canada and beyond are coming to Equinix to extend the reach of their networks. And that is why this statistic is real. But how it ties into the IoT conversation is when we think about how that traffic is getting to Equinix, it can come into Equinix through any flavor of connection. It could be internet, it could be MPLS, it could be layer 2 and even layer 1 wavelength private lines. We don't care how it gets here, but once it's here, the thing that we're finding, and this is actually coming from an assessment that we did across both ourselves and every interconnection provider like us globally, is that the need for private interconnection, which means sharing data effectively across a single mode fiber cross connect or a private connection that is not touching the public internet, the need for those types of connections are growing at an exponential rate. And it touches every vertical, whether you're in oil and gas or healthcare or you're in the public sector, every single vertical in the world is being affected by this because it's how these IoT capabilities need to be connected. So, and Kyle will go into a little bit more detail here, but I wanted to highlight this because it's just a fundamental piece of why we're involved in this conversation. So the next piece I just wanted to highlight was really, once again, with IoT, in order to optimize performance, distribution is critical, right? Solving for latency is critical. But even if you think about North America, think about, all of the investment that providers like Rogers and Shaw and every carrier in North America and Canada is making to not only extend their wireline networks, to extend their mobility coverage, and new players coming in to extend that coverage to the far-reaching areas like satellite providers. The ones that you know about are ones like Viasat and SES and HughesNet, and they all peer at Equinix. And you have new players like Starlink through SpaceX building out low orbit satellite coverage that's going to literally provide, by the time they're done, up to 100 megs of download across every inch of the globe within 50 milliseconds from any endpoint device. These are game-changing ideas, but they're all flowing back to these peering points where the public clouds are all built and accessible. And this is really the key that we're finding. It's about a balance, finding the right balance of building yourself control points, network aggregation points that allow you to take control of where that data flows and how to reduce the friction that any IoT endpoint is actually experiencing. So when you think about what that's meant for, let's just talk about the energy sector. In the past, all of these pipeline assets that all of these operators are managing, these are very extremely geographically distributed assets, right? That in some cases, maybe you're being connected to with MPLS networks. In a lot of cases, because of the distance, these are literally SIM cards in a remote device that's letting it know twice a day whether it's alive or not. And these are things that are now being optimized through SD-WAN and other technologies, because there's a huge need for real-time analytics around the health and efficiencies and securities occurring across those pipeline assets and other drill rigs, et cetera, in the field, right? So distribution is key, and that is what we do. This map I wanted to highlight because it's a very North American example here. But if you have these endpoints established with Equinix, our relevance here is that you're able to bring in whatever network you might choose to leverage. This could be a layer 2 private line from a carrier like a Shaw or a Rogers, even an MPLS connection to these hubs, and soon, and what we're seeing quite frequently is a migration towards even leveraging SD-WAN devices within these geographies that can all come back to these cloud adjacent distributed hubs to give you complete control and optimize the experience and throughput for those remote sites. So I'm going to be quickly handing it over here to Kyle, but the key things that we see driving the need to change, obviously, everything about our space is growing in complexity. 3 years ago, we were running RFPs between clouds to see which cloud would be the right answer for any specific enterprise. Now we're seeing our customers really start to leverage, once again, the right cloud for the right strategy at the right time, and giving themselves the choice. And when it comes to the innovation occurring, and this was actually a stat that was about a year old, Gartner was predicting that by 2021, that 1 million new IoT devices would be sold and deployed every hour by 2021. This is a huge explosion, right, in that space of the need for more devices and more analytics. And obviously, in order for those things to operate properly, once again, latency is key. Milliseconds matter, right? And this stat is coming directly from kind of the financial ecosystem, where in that world, $4 million could be lost every millisecond you're behind your competition. And that holds true, by the way, at least in part, around the need for speed is critical across any enterprise now to allow those applications to function the right way. So the last slide I wanted to highlight here is this is really where everything is connecting. When you think about Equinix as the intersections of the internet, of the clouds, of the financial ecosystems, of all the networks and content players, our whole goal is to now give every enterprise the ability to plug themselves directly into this ecosystem. And we have tons of examples of that here in Western Canada and in Alberta specifically. But I just wanted to highlight this because that is exactly the role that we're playing. And with that, I will hand it to Kyle.
Now working while I'm on mute. Okay, so thanks, Chad. So Chad has given you a 50,000 feet view of where this interconnection comes in and what we actually do. So what I'll be able to share is some of the use cases where how our customers are using our platform. And so some of the differences when considerations when you want to design or deploy your IoT solutions. This could apply whether you're IoT solution providers, whether you're business partners, or whether you are end users thinking about adopting IoT solutions. The point is the infrastructure doesn't matter, right? So here on the slide, on the left-hand side, you'll see a very traditional, a very common enterprise architecture for their infrastructure. All the data is collected through your endpoints, and then they are sent through your network carrier to your corporate data center. That's the corporate data centers, everything is crunched, and then send the results back out. In a traditional sense, in probably 2 decades ago, when the traffic flow is simple and it's minimal, this works really well, right? But as you have seen, the semiconductor technology has evolved over the past couple of years with the Moore's law. Your endpoint devices are become really smart, has a lot of compute power, has a lot of storage power. So the way that you generate your data is growing exponentially, right? So this traditional architecture is going to give you a lot of problem, right? So it is going to give you a performance problem. It's going to give you user experiences issue, capacity challenges, etc. Right, and that's why many successful companies have been looking at a distributed architecture, right? So in this particular case, then you want to build your resiliency into your network fabric. You have the different control points, as Chad mentioned, built into your different geographic points where your data is consumed or generated, right? And this also serves your purpose for disaster recovery or business continuity protection purposes, right? So you'll see a generic trend of moving from a traditional centralized architecture moving towards a distributed architecture. Now, this is one of the typical ways that an IoT solution architecture is deployed, right? So you have your remote data generation on the left, and this is where your data is generated. It could be coming from your headquarter office. It could be coming from your branch office. And for some of these IoT solutions, your data could be coming from your endpoint devices or your LP1 gateway, right? So you have your endpoint devices start generating data. They send the data over to a gateway, and that gateway is somehow connected to your network service provider, right? In many cases, the data sent to your network service provider, and that network service provider will send the data to, will have a lease line to your corporate data center, right? So in many cases, it depends on the amount of your corporate data and budget. This could be a couple cabinets inside the basement of one of your buildings, or it could be several racks of compute storage network in one of your third-party colocation data centers. So in the case that you want to utilize some of the new machine learning and artificial intelligence capabilities of the cloud, then in that particular case, you have to have a lease line to a third-party data center, not necessarily your NSP data center, but it has to be a data center where there is an on-ramp presence of your cloud service providers. And what will happen is that data gets sent over MPLS connection, and then that data will get sent over to the cloud to be able to utilize these capabilities, right? So as you can see, you have to send the data out. You have traverses through several networks in order to get to the cloud. And then if you're thinking about a global scale, this is not going to work, right? So the point is, this is will be inefficient, this will be expensive, and this will give you a bad user experience, right? So what happens is that what's the alternative, right? So, and this is a common deployment for many of our customers today. That included service providers, that include enterprises, etc. Right? Last mile activity, connectivity, this part will remain the same. You will still need this last mile connectivity, right? But as Chad also mentioned, as the technology evolves, you are going to start to have different options for your last mile connectivity, which I'll show you later as well. But the key point is, don't run your own data center. It costs a lot to run your own data center, right? And it creates a lot of infrastructure issues unless you are running a multi-megawatt workload, right? There is a variety of data center operators out there. You can select, you can pass your workloads to, but there's a couple key questions that you want to ask before you select your data center. The first thing, question one, are they carrier neutral, right? So as I mentioned before, when you are stuck with one network service provider, you have your lines connected to that network service provider, and then you're bound to that network service provider's capability and scalability. when you actually select a third-party colocation data center provider with a network service-rich ecosystem, you can actually select whichever that fits your best performance, business requirement, and technical requirement in terms of your network connection, whether that's the last mile connectivity or that's going to backhaul connections between your branch offices or remote sites, right? And those connections you have to also consider on a global level, right? You're not necessarily only deploying your solutions within Western region of Canada, but you can potentially have your solution deployed in EMEA or in Asia, right? And that's also important in terms of having a NSP-rich ecosystem for you to be able to select the best network service provider that fits your business purpose. Question 2, do they have direct on-ramp to 2 or more cloud service providers, right? Do they only have a presence to on-ramp to the AWS? But so what happens when you actually want to use the IoT Edge in Azure? What happens when you want to use the BigQuery capability in Google Cloud? Then that's a consideration that you want to implement take a consideration into your IoT solution. Some of these data centers, they have all the different connections, like say, preferably Equinix, of course. But there's also restricted capability that's only limited in certain data center from some cloud service providers. For example, Google Cloud, they actually have about, I think it's 11 now, low latency regions that's deployed in some of the selected partner data center, right? So how important is latency for you, for your application? How is that important to your real-time analytics? And you have also take that into consideration when you're actually selecting data center that contains on-ramp to the clouds.
I wanted to add one thing if I could to that, Kyle, if that's
sure.
all right.
Yeah.
Just so specifically when we think about Western Canada, this is something that we talk about a lot. And the concept is it's about finding the right balance. And because there is no public cloud compute yet deployed in Western Canada, this is a conversation we have a lot. And it, for me, is one of the things that really highlights the dramatic importance of actually that legacy. I'm not saying legacy, but the carrier data centers that exist today in Western Canada, right? So whether that's a data center that Rogers owns, or Bell, or Shaw, or any one of the providers that you work with today, there are certain workloads that simply require that low latency, and there's a need to maintain certain things in province, in country, right, that maybe tie into a hub like this at Equinix and into public cloud compute zones. But one of the things that we architect is around finding the right balance. So there's actually a really big importance to understand what those latency requirements are for those specific workloads. Right.
Thank you, Chad. And the last question, not this question, but last question, there's also what are value add services that these data center providers can provide, right? So there's a lot of new services that these data center providers are coming up. Do they offer precision timing services? Do they offer key management services? Or do they actually even offer, like, for example, bare metal as a service, right? Those different services will actually help you to optimize your IoT solution stack, and also the connections, the performances to your customers and to your business partners within that ecosystem. So in this particular case where your data is coming in directly through your NSP presence in that particular data center, in this case, it will be an Equinix data center, and instead of going out back to your corporate data center, if you have your cabinet sitting right in that particular physical data center, that data will get readily moved to that cage of yours. That's where you crunch most of your on-prem requirements. And then if you have a need to go out to the cloud to grab the specific capabilities, machine learning capabilities, deep learning capabilities, and you can go through a virtual connection or physical connection to connect to the cloud and start pumping the cloud data out to the cloud, which is free from the ingress perspective to the cloud. And then you get the results back after all the calculations is done in the cloud, right? This is also particularly good for compliance purposes because some of the countries, they have restrictions where data have to reside within that particular region. So you can imagine how this will work on a global basis as well. Okay. So taking a different approach, right? So this is a different case of utilizing the architecture, right? So as Chad mentioned before, there are several vendors to start to deploy low Earth orbit satellites. These can go up 100 megabit per second with less than 40 millis of latency. This is particularly good for your IoT data collectors that's out in the remote regions. Or if you have for example, a moving locomotives, in which one of our customers is actually doing that, is you'll be able to collect all your data, the sensor data on your locomotive, aggregate them, and then transmit that through your last mile connection over to either your network service provider through a 5G connection, LTE connection, or through your satellite service provider. And again, since those service providers are here locally in the data center where everything else resides, you don't have the security issue, you don't have the performance issue. And given that some of these connections to the cloud are actually virtually managed, you don't even have to send anyone to the data center to do any work, right? So everything can be provisioned very quickly over a period of, let's say, 15 minutes, and you already get your connection up running, right? So the point for this particular slide is basically by utilizing, when you actually deploy your IoT solution, whether you are a business partner, whether you are an end user considering that, in order to optimize your IoT solution for real-time analytics, you need to consider your infrastructure. Key points, you have to have a multiple selection of your network service providers, and you also want to be able to access the cloud from a multiple options. Okay, just going back to the diagram that Chad showed. So imagine how you have deployed this, and imagine that deployed on a regional or global scale. That's where you have a visibility of everything coming from your remote assets or your remote offices, going to the nearest carrier neutral multi-cloud accessible data center, and then how that could connect to the different assets around your regions, right? So if you're running a global operation, you don't necessarily only have your assets here in Western Canada. It could be somewhere in Houston as well, or it could be somewhere in Dubai, right? So that's just kind of a demonstration of how that works on a global scale. Now, this particular slide is actually food for thought, although some of our customers are already moving in that direction. Traditionally, when we introduced the internet, we have introduced the concept of a two-tier application design, right? So it's either you have your data processed in the client, or have then a process on the server. Now, a very typical example of that was active server pages, if anybody remembers that. Now, given that the amount of data that's been generated over here and the amount of data processing capacity on the cloud significantly increased, we start to see an emergence of a hybrid regional core to actually acting as a bridge, right? Because you cannot simply just process everything on the client, and yet you don't have enough pipeline to send everything to the cloud or your backend servers processing, right? So you can consider this as in something happens, you want to send a snail mail to get your response, or you want to send an email to get your response, or if you want to get a text message across, right? So it gets the application designers to start to think about, okay, now I have my information collected on my endpoint device. Do I have the information process in the original core, or do I have the information process in the cloud? That will matter for your user experiences and also for your real-time analytics, right? I think I'm gonna just to give a lot of real examples, like there's tons of right within automotive industry, within the elevator industry for predictive analysis, and also in the rail industry, and as well as the pipeline industry, that you start to collect the sensor information and doing real-time analytics, having a global operation dashboard, right? So just to give you some examples of that. Now, having said that, what are the impacts? You know, we talk about through the different use cases, different solution architectures, different ways to implement these connections. What are the impacts? You'll have access to this deck later, so you can take a look in more details. For those that are not familiar, the Total Economic Impact Study by Forrester is basically an independent commission report and study. They actually go out to interview actual customers, and they establish a composite company, and they study the impact of actually using interconnections. Right. So here you see some of the return on investment numbers, the network present value, and etc. And also, again, you'll get the deck later. These are some of the quotes from the customers indicating, you know, how much they have actually improved by adopting this distributed architecture with the interconnection centered oriented architecture. Okay. So this is pretty much marks the end of the presentation. Back to Brenda, or are we gonna go into a Q&A session?
Definitely. So anyone who has questions at this point, please feel free to either unmute or send through chat.
Oh, this is Terry from Microsoft. We work pretty close with Equinix with our express route. And you know, one of the biggest things we push with them, reasons we really like them, is the predictability of the latency that we get across their network. So if we have a private network like that, we can, you know, with the public internet, you really don't know how much latency you're going to get because you don't have control of it. But going through a company like Equinix, you can get that predictability. So it's just a comment, not a question.
Thank you, Terry.
Thank you, Terry. Yeah.
Any other questions? I'm actually very impressed how quiet this crowd is there. I was going to say at this point, if we can stop sharing, and if everybody would be comfortable unvideoing and like coming live and unmuting, we would be able to continue this conversation kind of almost face to face. There we go.
Absolutely.
Wow. So is there any questions that anyone has? I mean, you have two very knowledgeable people here on the line right now. How many people are actually dealing with Equinix right now on this call?
I just noticed in the chat that my presentation was static. Was everything? Did everything turn out okay though?
It did.
Yeah, no worries. I think we were.
Sorry, I was going to say you were a tad static, but not terribly bad. I think everybody could still hear you.
Okay, great.
Yeah. I was going to say, so is anyone on the line here that actually deals with Equinix right now, or are you all new to them? I know, yeah, Terry, I was going to say most of the Microsoft community would, yes. Matt Heron, I would assume you guys deal with them?
Yeah, we deal quite a bit together, and it's a nice little ecosystem where we act as the handoff in between their carrier hotels, and yeah, it's been a great relationship. Chad and I have worked together for a very long time, dating back to before he was with Equinix. So for any of you that have not utilized or engaged Equinix for any requirements for your clients, or if you are a potential customer, please don't hesitate to reach out to these guys. They're a wealth of knowledge.
Yeah, for a lot of the IoT solutions, I guess infrastructure does not come to as the first thought. But as I mentioned, infrastructure does matter, especially when your IoT solution is latency sensitive, when you want to have an overall global dashboard for your clients. It's very important to have that expected latency information, as Terry mentioned.
And one other point that I was going to make, and Terry, I appreciate what you're highlighting about what we're doing with Microsoft. I think it's just really important for the broader audience. And I mean, we're doing so much with Microsoft across all of Canada and frankly the world. They are our largest partner globally in the space when it comes to. We are the largest express route provider for Microsoft. So huge mass mutual investment there. But what I wanted to highlight was, as if you're building these solutions with customers and how much you're going to be leveraging Azure for these solutions, you hear a lot about express routes. And one of the things that we are uniquely differentiating that space is, once again, we're able to funnel every single IP endpoint, whether that's literally an internet feed in the field coming from a satellite link, or an actual high capacity fiber link coming from your data center today. When it comes to the express routes that Equinix can provide, we can take all of those inputs, and literally land them on high capacity routing infrastructure at Equinix that funnels all that traffic into Microsoft, right? So thinking about express route differentiation, this is really why we work so closely with Shaw and with other carriers, in Canada, like Rogers and everyone else, is that is the critical piece. They own the last mile, and without the last mile, we would not be able to bring that data into these, data gravity centers, right? And so with Microsoft, it's just very unique because, what might, when we think about how we're able to move that data into the cloud and then make it, accessible and be able to deliver the results, that's how we're doing that.
Thank you, Chad.
Yep.